One of the problems I had for this week was problem 40, and in problem 40, a 50 kg sprinter starting from rest runs 50 meters in 7 seconds at a constant acceleration. Part A, what is the magnitude of the horizontal force acting on the sprinter? And part B, what is the sprinter's power output at 2, 4, and 6 seconds? So before we begin, some important concepts to understand for this problem, and just that we talked about in class, are working kinetic energy as well as Newton's second law and power. We will be using these concepts as well as equations throughout this problem. And then down here, I've just drawn a little figure of our sprinter starting from rest, and then they're going to accelerate at a constant rate until they reach the 50 meters after 7 seconds. And then I've just also illustrated the 2, 4, and 6 seconds because this is where we'll be determining the sprinter's power output at these specific times. And so moving on to part A, we need to find the magnitude of the horizontal force acting on the sprinter. And so to do this, we will be using these two equations right here. This first one being the acceleration of the sprinter coming from the kinematic equation, and then this one right here being Newton's second law. And so to start, it's important to note that because the sprinter is starting from rest, the initial velocity will be 0. And so because the initial velocity is 0, this whole term goes to 0. And so we can then rewrite this term to solve for the acceleration, because we need the acceleration in order to find the horizontal force acting on the sprinter, or the magnitude of the horizontal force acting on the sprinter. And so when we rearrange it, we get this new equation right here, and we can plug in what we know to find an acceleration of 2.04 meters per second squared. We then plug that into Newton's second law equation, and we get that the magnitude of the horizontal force acting on the sprinter is 102 newtons. And so moving on to part B, we are solving for the sprinter's power output at 2, 4, and 6 seconds. And so to do this, we will first be using this equation right here, as well as the power equation right here. And so first we need to solve for the velocity so that we can use the power equation, and that's exactly what this first equation is for. And so, as I stated earlier, just important to note again that the initial velocity will be 0 because we're starting from rest. And I also just wrote a little note right here that cosine of 0 degrees is equal to 1, and here will be a cosine of 0 because we're just horizontal, and so there is no angle. And so you don't need to write cosine for the rest of the equations. I didn't for my 4 and 6 seconds equation just because it's equal to 1. So it's just an important note. But moving on, we just plug in what we know. So we have our acceleration and then our time, and we use that to find our velocity, and then we can plug in the velocity into the power equation to find the power output. And so for 2 seconds, we see that it is 416.16 watts. And then using the same process for 4 seconds, using the same acceleration, and then 4 seconds, we get our new velocity. Plug that into the the power equation, and we get 832.3 watts as our power output. And then finally at 6 seconds, we plug in and find our velocity, and then use that to solve for power. And for the 6 seconds, the power output is 1,248.5 watts.